In the first question, we have been asked to find the Laplace transform of e power minus 2t cos square 4t. For that, we will use shifting rule. We will find the Laplace transform of cos square 4t, and cos square 4t can be written as half 1 plus cos 8t. Applying the standard formula, we will get this final equation. Now, we have to apply the shifting rule. What does shifting rule say? This is e power at. So, what is a? A will be minus 2. So, replace s by s minus a. What is s minus a? S plus 2. So, in each place where s is there, we will replace by s plus 2. Okay. In this question, we have been asked to find the Laplace transform of 1 minus e power t divided by t. So, first we will find what is the Laplace transform of 1 minus e power t. After getting that, since it is divided by t, we have to find the integral of this function. After finding the integral, we will apply the limits and simplify it to get the final answer. In this question, we have been given with trigonometric function as well as multiplied with t. So, for that, first we will find the Laplace transform of the trigonometric function by separating it and then applying the standard formula. After that, we have to differentiate it like I have showed in the next question. See, Laplace transform of t cos 2t. First, we will find this Laplace transform. After that, we will differentiate it and get the final answer. Similarly, here also I had to do I forgot to write the differentiation part. Okay. So, moving on to the fourth question. Here we have three functions, t, e power minus 2t and sine 4t. First we will find the easiest one. Sine 4t is the easiest one. By applying the standard formula, we will get this equation. After that, we have to multiply with t, so we will differentiate this equation with respect to s. After that, we have to apply the shifting rule by e power minus 2t, so s will be replaced by s plus 2. In this question, the Laplace transform of the numerator will be found first by using standard formula, and then since it is divided by t, we will find the integral of it and apply the limits to get this final answer. In this question, we have been given with three trigonometric functions. So, first we will combine first two trigonometric functions by converting the product formula into sum formula. Okay. After doing that, we will multiply cos 3t inside this bracket and we will obtain two terms. After that, we will apply the same thing here also, since we have two terms here, and then we will apply the standard formula to get the final answer. In periodic function, the standard formula is given by this, where t is the period. In our question, the period is 0 to a. See, this is 2a. Okay, so the period is given as 0 to a, and we'll apply the value of t as a, and after that we'll apply the value of f of t also. Since f of t is defined as e in the range 0 to a by 2 and minus e in the range a by 2 to a, we will be separating the integral as 0 to a by 2 and a by 2 to a. So, here we will apply the first f of t, which is e, then we will apply minus e here. Then it is just simplification part, and you will reach this step here. This step can be simplified further as 1 minus e power minus as by 2 whole square. Okay. By expansion formula, we will get this equation. Okay. So, after that we will simplify it by cutting out the similar terms, and then tan as formula. See, this tan as can be written in the terms of the powers of e in this way. Okay. So, you have to make a small correction here, means modification here. See, it is e power minus a by 2, that you have to multiply by 2 and divide by 2 here. Okay. So, it will be minus 2 as by 4, because the formula is of that type. You have to get 1 minus e power minus 2x. Okay. So, to get minus 2 here, you will multiply and divide by 2. After that, you will write the value of theta here, which is as by 4. Okay. In this question, we have been given f of t defined as f1, f2 and f3. This is f1, this is f2 and this is f3. Okay. And a and b is 1 and 2. After knowing that, you have to write the standard formula and apply the values. Okay. Applying the values, f of 1 is 1 and f of 2 minus f1 is t minus 1 into u of t minus a plus t square minus t, which is f3 minus f2, and u of t minus 2, t minus b. Okay. After writing that, you have to consider each term and find the Laplace transform. The first term is 1. Laplace transform of 1 is 1 by s. So, we will move on with the second term, t minus 1 into u of t minus 1. we'll consider t minus 1 as f of t minus 1 is equal to t minus 1. Now we need f of t. To get f of t, we'll add 1 in this side and this side also. So we'll get f of t is equal to t. After finding f of t, we'll find the Laplace transform of f of t. We'll get 1 by s square. After that, we have to multiply by e power minus as. What is a here? A is nothing but u of t minus a, 1. So e power minus 1 s will be multiplied with L of f of t. Okay, so it will be e power minus s by s square. After that, we have to do the same thing for the second term also. We will consider this term as f of t. Okay, see here, we will consider f of t minus 2 as t square minus t. Okay, and then to get f of t, we will add 2 here and we will add 2 here also, means we will replace each t by t plus 2. Okay, and we will expand it by using the formula and we will get this equation here. Now we have to find the Laplace transform of this equation. By applying standard formula, we will get this equation and we have to multiply by e power minus as. What is a here? A is 2 here. So e power minus 2s will be multiplied with L of f of t. After that, we will write the 3 equations which we got, 1 by s for one, and this for the second one, and this which we got here. Okay, that will give us the final answer. In this question, we have been asked to find the Laplace transform of this equation. In this function, we have to separate the a part and b part by taking the denominator as s plus 1 and s minus 2. By partial fraction method, we will get the value of a and b, and we will be substituting the value of a and b in this equation, and then finding the Laplace transform by standard formula. Okay, so we will get the final answer here. In the next question, we have been asked to find Laplace transform of inverse Laplace transform of cot inverse of s by a. Now pay here attention. F of s is equal to consider f of s as cot inverse of s by a. So differentiating it will give us f dash of s. We are doing this because there is a formula in which we can apply and get the answer very easily. Okay. After finding f dash of s by differentiating it, we will apply this formula. L of t into f of t is equal to minus f dash of s. We will be applying f dash of s which we got here, and that will be written as L of f of s. See, L of t of t is equal to minus f dash of s. We will be multiplying the Laplace transform in the other side, so it will be inverse Laplace transform, and the t will be taken in the denominator. We will be remaining with f of t here. So then what we have to do is we have to find the Laplace inverse of f dash of s. Okay, so we will be applying the value which you got here, f dash of s value, and finding the inverse Laplace transform, and we will get minus sine a t. After that we have to divide by t. Okay, that will be the final answer. For this question, we will be considering this term as f of t. Then we will be shifting L inverse on the other side. So we will be getting L of f of t is equal to log s square plus 1 by s into s minus 1. What is L of f of t then? Log s square plus 1 minus log s into s minus s plus 1. So we will be multiplying with t in the next step. For each question, it's a different method. So in this question, we will be multiplying by t. So we will be obtaining this equation, and then we will be simplifying here. After that, we will shift L here to get L inverse. Then we will be applying the standard formula on this to find the L inverse of each of these, and after that, finally, after getting the L inverse, we will divide by t. Okay, see here it was t into f of t, right? So to get f of t, we will be dividing by t. Okay, in this question is also same. We have been given with L inverse of this is equal to f of t. So we will be shifting L here. So we will be getting L of f of t is equal to log s plus a by s plus b. That will be written as log s plus a minus log s plus b. After that, we will be multiplying with t and differentiating it and finding the L inverse of it, here, and then divide by and then finally to get f of t, we will be dividing the RHS part by t. Okay. In this question, it's possible to factorize the denominator. So first, consider the denominator s square minus 6s plus 13. Okay, that can be written as s minus 3 whole square plus 2 square. Okay, and s minus 3 whole square plus 2 square, and in the numerator also we need s minus 3. Why? So that we can apply the shifting rule. Okay, so how we will get s minus 3 in the numerator? See, what's the numerator here? It's s plus 5. So what we will be doing is we will be subtracting 3 and adding 3 also. So we will take s minus 3 as same term, we will group it together, and 5 plus 3 will be taken together. Okay, so we will get s minus 3 plus 5 plus 3, that will be s plus 8. Okay, after applying the shifting rule, and after applying the shifting rule you will convert s minus 3 as s, okay, in the numerator as well as denominator. After that we will find the Laplace transform by using the standard formula, and that's the final answer. This question is pretty simple because the denominator can be factorized by factorized as s plus 3 whole square, and we'll use the shifting rule to make the denominator as s square, and after that we will apply the standard formula. In convolution theorem we have been given with f of s and g of s. First we will be finding what is f of t and g of t. Okay, after that we will find the Laplace transform of this main, which is given term as L inverse of f of g into f of s into g of s as f into g. Okay, that's equal to integral 0 to t cos a into t minus u into cos bu. Now what is cos a into t minus u? The first term, which is f, that has to be written in the form of f of t minus a. Okay, and the second one, which is g of t, will be written as such. Okay, g of t only. So in that way we will get this term here, and after that we will convert the product formula into sum formula by using the trigonometric formulas, and then we will apply the integral to simplify cos into sine, and then we will simplify it further to write the final answer. In difference equation we have been given with this equation, and the initial conditions are also given, and for each of these, see, d square y by dt square can be written as y double dash. Similarly dy by dt can be written as y dash, and y will be the same thing, and 5 sin t will also be the same thing. After that there is standard formula for what is L of y double dash, what is L of y dash, and L of y. We will be applying those formulas here, and we will be taking L of y common and simplifying the equation which we got here by using partial fraction method. And observe here, both of these terms are unfactorizable. So what we will write is s square plus 1 will have the numerator as as plus b, and the second term will have the numerator as cs plus d. We will apply the formulas to get the values of a, b, c and d, and we will find the Laplace transform by using the standard formula. F of x is equal to pi square by 12 minus x square by 4. This is an even function because if we apply minus x here or x here we will get the same term. So b of n is 0, and this is the standard formula, a naught by 2 plus a n cos nx. Okay, and we will be applying the a naught formula here and finding the integral. Similarly we will find the integral for a n also. Okay, and after that we will apply the standard formula here to get the final answer. Now they have asked us to deduce something, right? See here in the question they have asked us to deduce the following series. So for that what we will do is we will take x as 0, so we will get f of x as pi square by 12. Why? Because what is pi square by 12? See, if you take x as 0 here, this term will be cut, we will be remaining with pi square by 12. So pi square by 12 will be here, and in the other side we have cos nx will become 1 cos 0, and this n will be altering the values of minus 1 and 1. Okay, so on expansion we will get this series here. Okay, the formula for half range cosine series is a naught by 2 plus summation n is equal to 1 to infinity a n cos n pi x by L. Now what is a naught? A naught is 2 by L into integral 0 to L f of x dx. F of x is given as x plus 1 whole square. So we will be applying f of x here as x plus 1 whole square and applying the limits, we will get this answer here. Similarly for a n also the same thing, but the f of x will be multiplied with cos n pi x, and we will be applying the limits to get a n here. And by after getting a naught and an values, we will be applying those values in the main equation and we will get this final answer. This is the formula for half range sine series, and in this first we will apply the value of f of x, which is given as e power x. Okay, e power x will be replaced by f of x and sin n pi x will be here. Now the standard formula for e power ax sin bx will be applied, and on applying the limits we will get this final answer, and after getting what is bn we will be applying in the main equation. Okay, this is the final answer. In this question f of x is even function, so b of n will be 0, and we will be applying the limits from 0 to pi for a naught and a n. We will be applying the formula for each of these and getting the final equation here. To deduce the series, we will apply x as 0, so the cosine x will become 1, and we will be observe here, it's the numerator is minus 1 power n minus 1. Now if n is an even number, that time this answer will be 1. Here it is minus 1, so it will be 0. Whenever n is even, the answer is 0. Whenever n is odd, the answer is minus 2. So for each odd terms in the denominator, we will write as minus 2 in the numerator, and for the terms which are even, we will write the numerator as 0. Okay, in that way we will expand and take minus 2 common here with with 2 here, that will give us 4. Here we have 2, so that will multiplying that will give multiplying 4 with 2 will give us 8. So pi square by 8 is equal to 1 by 1 square plus 1 by 3 square plus 1 by 5 square, and so on. F of x is given as x square, so we have to find out a naught and a n. Okay, since f of x is even, a naught formula is this, and we will apply this limits to get this answer, and we will do the same thing for a n also, and after that we will apply the values of a naught and a n in the main formula, and we will, to deduce the series, we will put x as 0 to get the series. Okay. In harmonic analysis, first we have to find out the period, which is 2L, that is t, because the values are going from 0 to t. The last value I have omitted because the term is same, means 1.98 only. In that case we will have 6 terms here, so n's value is 6, and we have to find out theta. Okay, theta will be pi t divided by t by 2. The actual formula for theta is pi x by L. So L is t by 2 here, and x is, instead of x we have t here. So we will be using the value of x as t, and we will be getting theta here. In the next step, we have to make this table. In this table, the values of t will be written as well as theta. Then we have to find out a cos theta and a sin theta. What are the values of a? In this question which they have given, these are the values of a. We will be writing these values in this column and finding what is a cos theta. For each value, a will be multiplied with cos theta. Okay, and similarly for a sin theta also. After that, we have to find the summation of a cos theta and a sin theta. After getting the summation, we have to find out the values of a naught, a1 and b1. Okay, by using this formula. Then finally we have to write in the form of harmonics, first harmonics, a1 cos x plus b1 sin x. a1 is the value which you got here, that multiplied with cos x we will write as same, similarly for sin x also. This is the standard formula for the Fourier transform, and the limit is defined only in the interval minus a to a, rest all it's 0. So we will be considering this interval here minus a to a, and we will be applying the value of f of x there, and we will be integrating it to find the final answer. In next step, we have to evaluate the equation which they have given. To evaluate it, the equation which you have to write is the inverse formula. Okay, inverse Fourier transform. So f of x is equal to 1 by 2 pi into integral minus infinity to infinity f of s into e power minus isx ds. Now f of s which we got here is this one. Okay, this is f of s. We will be applying f of s value here and then integrating it. So before that we have to check if the function is even or not. It's even because sin as is odd function and s is also odd function. Odd by odd is even function. So we will have even function here, and in the question they have asked us the value of sin x by x dx. So e power term is not there, so x term we can take as 0 to eliminate the e term. Okay. After that put a's value is 1, because in the question which we have to prove it's just sin x. Okay, so a's value is 1. On integration, we'll be integrating it to get the final answer, which is pi by 2. The infinite Fourier sine transform is f of s is equal to integral 0 to infinity f of x sin sx dx. We have been given with f of x, which is e power minus mod x. Okay, so we'll be applying the value of e power minus x here, and in the integral 0 to infinity, since it's positive term, since it's positive interval, we'll have mod x value as x. Okay, so it will be e power minus x into sin sx. Now by using the formula of e power ax sin bx, we'll be simplifying it and writing the equation here, and then we'll be applying the limits to get what is f of s. Similarly, we have to find the inverse also. In the next step, we have to write the inverse Fourier sine transform, because we have to get this equation here. So for that, f of s value we know, we'll be using this value here and simplifying it to get the final answer. Okay, after that we'll apply the limits as, see, in the final equation we have to prove in terms of x, right? So s will be converted into x, wherever s is there, write x there, and we have to take the f of x value as x is equal to m. Okay, if we take x is equal to m, at that time we will get the, see here, what is f of x? It's e power minus mod x. So if we take x as m, we will get e power minus m. So similarly we will do here also. Instead of f of x, we will use the value of f of x as e power minus m, and we will get this final answer here. In this question we have been given to find f of s of the term f of x, which is given as a square minus x square. So the limit is only defined where a square minus x square is there, that means minus a to a. Okay, rest all terms will be 0. So considering the limits minus a to a, we will be finding the integral and applying the limits. After that, when we get f of s here, we will use inverse Fourier transform formula to apply the value of f of s, which we got here. And after doing that, we have to find out, we have to put x is equal to 0 and convert s into x. Okay, after conversion we will get sin x minus x cos x by x cube, and since x is 0, e power minus isx will become 1. If you put x as 0, what will be value of f of x? F of x is a square minus x square. So if x is 0, f of x will be a square. So that we will write here, a square is equal to this term, and we will be shifting all the other coefficients on the other side, and just the integral part on the LHS. Okay, that will give us the final answer. In this question, f of x is defined as 3 intervals. First one is 0 to 1, then 1 to 2, then greater than 2. When f of x is greater than 2, at that time it is 0. So we will be considering just first two limits. Okay, so considering first two limits, we will apply the integration formula and we will find the Fourier sine transform. Similarly for cosine transform also we will do the same. We will consider the two limits and apply the formula and simplify it. Okay, in this question we have to apply the z transform on each of these terms. Okay, there is a standard formula for each of these that we will be applying here, and using the initial conditions which they have given, we will be using those values in place of u0 and u1, and we will be separating u of z from the rest of the term. Okay, after that we will shift this term in the denominator of the next term, and we will be remaining with u of z. After that we have to take z common from this and write it in the form of u of z by z, and then by direct formula, and we can apply direct formula because z minus 1 will get cancelled, and we have 1 by z minus 2 whole square. Okay, the standard formula for z by z minus 2 whole square is, the standard formula is n into 2 power n. Okay, in this question we have been asked to find out the z transform of cos n theta. Okay, so what's the formula of cos n theta in terms of e? Cos x can be written as e power ix plus e power minus ix by 2. Okay, so instead of x, what we have here is n theta. So we can write cos n theta as e power in theta plus e power minus in theta by 2. Now e power in theta can be written as e power I theta power n. So a will be e power I theta. Z transform of a power n is equal to z by z minus a. So if we consider e here, it will be e power I theta. Okay. So if we take the z transform, we will get z by z minus e power I theta here, and z by z minus e power minus I theta here. Next is the simplification part here, and here we will be multiplying by 2 and dividing by 2 to get cos theta, and here also we will be doing the same thing. Similar case is with the sin theta also. We will be using this formula, and by using this formula we will simplify it, and the difference comes here. We will be multiplying and dividing by 2. Here we will get sin theta, and the denominator will be same. Next, cos h n theta has this formula, and sin h n theta has this formula. Okay, the steps are the same. In the same way we will simplify to get the final answer. In this question we have been asked to find the inverse Z transform of the following. The first one, the question is given, we have to use partial fraction method. So we will be separating both the denominators, and we will be finding the values of a and b. Then by using the standard formula we will be substituting the values and getting the writing the final answer. In this question the numerator is z, so we will be taking u of z by z. So the numerator will be 1 here, and we will be separating as a and b, finding the values of a and b, and substituting back those values in this equation and finding the z inverse. Okay. In this equation is all. In this equation we have 18z. So after separation of the denominators, we are finding the values of a and b by using partial fraction method, and by applying the standard formula we get the final answer here. In Taylor series they will give you y1. Okay, if they give you y1, what you have to do first? You have to find out what is y1 of 0. y1 of 0 means you have to apply the values of x0 and y0 in this equation. x0 is 0 here and y0 is 2. When you apply here e power 0 minus 2, you will get minus 1 here. Similarly, to find y2, you have to differentiate y1 and apply the values of y1 and x0 here to get the value of y2 of 0. Similarly, you have to find y3, y4, and after that use those values in this equation to get the Taylor series in the form of x. Okay. Now after getting this equation, what they have asked here, find y of 1.1. So 1.1 is nothing but the value of x which we need to put in this equation. When you put here 1.1 in each place of x here and calculate the result, that will give us the final value, which is y of 1.1. Question we have to use the RK method. So we'll make 4 columns. First one is for x, y, f, and ki. Okay. So for x we will have x0, then x0 plus h by 2, then x0 plus h. Okay. Those values will be given in the question. We will be applying here, and similarly for y0 also we will apply here. After getting x0 and y0, we will find what is f by using this formula. Okay. After getting f, we have to multiply by h to get k1. Similarly, we will find the value of y1 y1 as y0 plus k1 by 2. After getting y1, we will be applying the values of x1 and y1 here to get the value of f1. After getting f1, we will be finding out the value of k2. Similarly, we will find the values of k1 to k4. After getting the values of k1 to k4, we will be using this equation to find out the value of y at 0.2. The equation and the table will be given to us. We have to find out the values of f0 till f3. After getting f values, we have to apply the f values in this equation to find out y4. Okay, and similarly we have to find f4. We will be applying the values of y4 and x4 to get the value of f4. After getting f4, we have to find out the value of y4c, that is corrector formula. Okay, in y4c we will be using the value of f4 which we got here, and by simplification we will get the final answer. In this question we will be given this initial values. We will be finding the value of f0 by applying x0 and y0. After getting f0, we have to find out the value of y1. Okay, we will make 4 columns then and write these values here, and in each step we have to find out the value of f1 here by using the values of x1 and y1. After getting f1, we have to find out the value of next y1. After that we will find the f1 and y1 values. We will repeat it 3 times and we will get y of 0.1. Now in the question they have asked y of 0.2, right? So we will be considering y of 0.1 as y0 and 0.1 as x0. and we will be finding new f0 by applying x0 and y0 values. After getting f0 we have to find out y1 and then do the same thing which we had done in the previous step. Okay, then we will get the value of y of 0.2. In our case method we will have been given with these values and we have to find out the value of f0 till f3. Okay, by using the values of f0 we have to find out the values of k1 to k4. By using this equation we will be finding the value of y0 plus k and then we will get the final answer. In this question we will have been given with x0 till x4 values as well as y0 till y4 values, and the equation will be given to us. We will have to find the values of f0 till f3 by applying the x and y values, and after finding till f3 we need f4 value. For f4 we need to find out y4p. By using this formula we can find y4p. By y4p we can find out what is f4. After getting the value of f4 we have to apply that in the formula of corrector method. Okay, after applying the value and simplifying we will get the final answer. This is y1 and we firstly we have to find out y1 of x0, which is y1 of 1. Okay, and after getting y1 of 1 we have to find out y2 by differentiating it, and we have to find what is y2 of x0. We will be getting y2 of x0, and similarly we will have to find out y3 and y4 also. After getting the values of y0 till y4 we will be using this those values in this equation, and after simplifying and applying the values of x which they have asked us to find out, which is y of 0.1. So we will be using the value of 0.1 in place of x and we will be calculating the final answer. In this question the value of y1 have been given to us and x0 and y0. By using these values we can find out what is f0, and by f0 we can find what is k1. After getting k1 we will find out what is y1. y1 is equal to y0 plus k1 by 2. Okay, so by using k1 value we got y1. In the same way we will find out the values of k1 till k4, and by applying those values in the equation we will get the y of 0.2 value. Okay, this is the data which has been given to us, and by using this data we will find out f0 till f3 values, and by using these values we will find out y4p, and by using y4p we will find out what is f4, and we will be applying f4 value in y4c. Okay, and simplify the equation to get the final answer. This is the same as the previous method, but in this method we will have the g term also. So firstly we will be considering d of y by dx as dy by dx as z. Okay, so d square y by dx square can be written as d of dy by dx, right? So d of dy by dx is z, so dz by dx will be written in the place of d square y by dx square. After writing the equation in terms of z we will be getting what is g of xyz. In the same way as we had found out what is k1 till k4 by using f0 till f4 values, like that we will find out what is the value of L1 till f4 by using g0 and g0 till g4 values. Okay, so for example see here, to find out the first L1 value, see here g of x0, y0 and z0. What's the values of x0, y0 and z0? 0, 1 and 0, right? So we will be applying that in this equation of g. So when we apply here 0, 1 and 0, at that time we will get the value as 1. Okay, so that will be multiplied with h into g will give us the L1 value. Similarly we will do for the other L values also, and by applying the formula we will get the final answer. If they ask us to find out what is the value of z at 0.1, at that time instead of k we will use L values. Okay, similarly in this question also we will do the same. We have been given with these values, we will find out what is k and L values, and finally substitute those values in the equation to get the final answer. In Milne's method this will be the equation which will be given to us, and the dy by dx will be considered as z. If dy by dx is considered as z, at that time d square y by dx square will be dz by dx, that will be 1 plus z, which will be the value of g of xyz. We have been given with the x and y values, and by using the x and y values, by using x, y and z values we will be finding what is f1 till f3, and similarly we will be finding what is g1 till g3 by using the f and g formula. Okay, by using these two formula, and then we will be finding what is y4p and z4p by using this and this formula, and after getting both we will find f4 and g4. Then finally we will apply the values of f4 and g4 in the corrector formula, and we will get the final answer here. We will be given with the values of dy by dx, we will be considering that as z, and then y double dash will be dz by dx. Then we have to either you can make this table and find out the values of k and g, or you can do in the previous way also, and after getting k and l values we will be using those values to find out what is y of 0.2 and z of 0.2. In this question also we will be doing the same thing. By using x0, y0 and z0 values we will be finding what is k0, and we will be finding what is k1, and by using k1 we will be finding the rest of the values. Okay, and the same thing is for L1 also. Okay, after getting k and l values we will be using those values in this equation to get the final answer. In this table we will have x and y values, and similarly f and g values. By using the each row value we will find out what is f0 and g0. By doing the same we will find the values of the rest of the f and g terms, and by using the formula of y4p and z4p we will be finding what is f4 and g4, and by using f4 and g4 we will be applying the values in this equation to get the final values, which is y of 0.8 and z of 0.8. This will be the question which will be given to us, and we have to make the diagram first. See here in this diagram you will make the x and y axis, and we will mention 2 points as x1 y1 and x2 y2. We will be joining these 2 points and mentioning that equation as y of x plus epsilon eta x. Then after that we have to write 3 statements, and by using these statements we will fill the values of f of x y z. Okay, f of x y and y dash. Here we will fill the values accordingly. Y value will be filled as y of x plus eta x, and y dash will be filled as y dash of x plus eta epsilon x. Now after filling the values here we will differentiate I with respect to epsilon, and here we will get del f by del x into del x by del epsilon. Okay, then for the next term y of x can be written as del f by del y into del y by del epsilon. In that way we will write the same for y dash also. After writing for all of these we have to separate these 2 terms, and then we have to integrate it separately. This del y by del epsilon can be written as eta of x, and del y dash by del epsilon can be written as eta dash of x. By using integration by parts we can integrate this term here, and we will be getting eta of x with the limits x1 and x2, and eta of x is same for x2 and x1 also. So this term will get as 0 when we subtract it, so this term will be cancelled, and the remaining term will be taken in common with the previous term. Okay, and after taking common we will be left with eta of x into del f by del y minus d by dx of del y by del f by del y dash. After that we will be writing this term here and equating it with 0. In this question the formula will be given to us, and we have to find out del f by del y and del f by del y dash. See, observe here, is there any y term here? No, right? So del f by del y will be 0. Similarly we have to find out del f by del y dash. Okay, here y dash is there, so on differentiating it we will get del f by del y dash as y dash by root of 1 plus y dash square. After getting these 2 values we will be using these 2 values in the main equation, and we will be writing and integrating it to get this term here. Okay, and we will be shifting the y dash on one side and the remaining constants on the other side. So since this is a constant, this can be taken as m. What is y dash? Y dash is nothing but dy by dx. Since we got here dy by dx as m, that means the slope is constant. That means if a slope is constant, it's a straight line. So hence the geodesks on a plane are straight lines. For this proof we have to write the f value first by using this equation, and since f is independent of x, we have no x terms here, so f will be constant. Okay, by using the Euler's formula we will be writing this term here, and we will be multiplying 1 plus y dash square in the RHS part and LHS part. So here the root will get cancelled, and here we will have the 1 plus y dash square. After that we will simplify it and integrate it. Okay, after integrating we will get as cos h inverse of y by c. On further simplification to get y term in the LHS part, we will be shifting all the other terms on the RHS part, and we will be getting this final equation. By using this equation, we will find out what is del f by del y and del f by del y dash. After getting that, we will be using those values in this equation, and then shifting and integrating, we will get the k term here, and on further integration we will get the final equation here, okay, which is a parabola. For this question, f will be this part here, okay. After finding what is f, we will find out del f by del y and del f by del y dash. We will substitute the values of del f by del y and del f by del y dash in this equation, and then simplify it to get the form like this, okay. And d square y by dx square can be written as the capital D square, and y can be taken as common, so it will be d square plus 1 into y, that is equal to sin x. Now by using auxiliary equation, we will find out the roots, which is 0 plus or minus I. We will be writing the YC equation. YP will be, YP is nothing but you will keep y here and shift the other term in the denominator, so you will get sin x by d square plus 1. Replace d square by minus a square. So when you replace it, you will get here as minus 1, and minus 1 plus 1 is 0. So since you are getting denominator as 0, you will be differentiating the numerator and the denominator and multiplying the numerator with minus x, okay. After doing that, you will get this equation here, and then we will write y as yc plus yp, okay. After getting y, the initial conditions which they had given to us, that will be used, and by using the initial conditions in the question, which is x is equal to 0, y is 0, and at x is equal to pi by 2, y is 1. So by using these two values, you can find out what is C1 and C2. After getting C1 and C2 values, we will be using those values in this equation to get the final answer. This is the final answer. In this question also, we will be doing the same thing. F of x comma y dash is equal to this term, and we will be finding what is del f by del y and del f by del y dash. After that, we will substitute the values of these both in this equation, and we will be simplifying to get y, okay. Here we will get y double dash plus y is equal to minus e power 2x by 2. The equation is same here, just the yp value will change, since it is minus half e power 2x is there. So according to that, for this question we will be replacing d by a, okay. When we replace d by a, we will get the denominator as 10 in the denominator. This is the value of yp. After getting yp and yc, we will be writing y as yc plus yp, okay. And by using the initial conditions, when x is 0 and y is 0, the question which they are given, right, it is passing to the point 0 comma 0 and 1 comma 1 by e. So this is nothing but x and y values. So when x is 0, y is 0, by using x and y values, we will find out what is the value of C1, and by using this value, we will find out what is C2, okay. After getting the values of C1 and C2, we will be substituting that in the main equation to get the final answer.